Hello, everyone, and thank you for joining us for the October meeting of the Linnean Society of New York. I'm Debbie Mullins, the president, and I call the meeting to order. We have a great program tonight, but before we get started, I have just a few announcements to make. To those of you who have paid your membership dues, thank you. And if you have not paid yet, please do so as soon as possible. Your dues are far and away our largest source of income, and they're truly necessary for carrying out our programs and activities. You may pay online by going to members.linneannewyork.org or by mailing a check to us at P.O. Box 801, New York, New York 10024. And apropos of tonight's presentation, the Lights Out Bill, Intro 896, that would require all privately owned commercial and industrial buildings to turn off non-essential lights during migration, is still pending in the City Council. Bright nighttime illumination attracts birds into the city where they're susceptible to collisions with windows. The NYC Bird Alliance has shown that up to 250,000 birds are killed each year in New York City in building collisions. So please write or call your city council member and urge them to co-sponsor the Lights Out Bill, Intro 896. And lastly, last week you were asked to vote on two motions, one to approve the minutes of the September meeting, and the second to approve the membership applications of 10 new members. The minutes were approved with 128 in favor, none opposed, and 4 abstaining. And the new member applications were approved with 131 in favor, none opposed, and 1 abstaining. So please join me now in welcoming these new members: David Berger, Allison Dundee, Ann Goodwin, Stephen Hubbard, Peggy Maslow, Joseph Navarro, Lindsay Drogan, Nancy Rosenberg, Susan Klingelhofer, and Joan Cade. Welcome to all of you. We're very happy that you've joined us at the Linnean Society, and I look forward to meeting you sometime soon, I hope. And I invite anyone who's watching tonight who's not a member to join. Our membership application is on our website, and membership is open to everyone with an interest in birds or other areas of natural science. So turning now to our program, as usual, we've disabled the chat function. So if you have a question for Dr. Farnsworth, please type it into the Q&A feature. And after the presentation, Vice President Doug Futuma will moderate a question and answer session. Andrew Farnsworth is a visiting professor in the Center for Avian Population Studies at the Cornell Lab of Ornithology. Andrew began birding at age 5 and quickly developed his long-standing fascination with bird migration. His current research applies remote sensing technologies, including weather surveillance radar, audio and video recording and monitoring tools, citizen science data sets, and machine learning techniques to study bird movements. He and his collaborators employ science to educate and engage audiences in conservation actions, notably with respect to reducing light pollution impacts on nocturnally migrating birds. He's also employed his extensive field and research background for consulting with the energy industry, municipalities, and research institutes. Andrew received his BS in Natural Resources from Cornell, an MS in Zoology from Clemson University, and a PhD in Ecology and Evolutionary Biology from Cornell University. And he lives right here in New York City with his wife and 2 daughters. He's also active in his family foundation, whose mission includes support for climate change education, promoting women's health and rights, children's education, and conservation. And when time and space allow, he's also a musician. So we're very happy to have Andrew with us tonight. The title of his presentation is Bird Migration in the Era of Big Data, BirdCast's Perspectives on the Future of Monitoring Migration Birds. So thank you very much, Andrew, for being here tonight.
Debbie, thank you for that introduction. Makes it sound like I've done a lot. I didn't think I was that old, but I think I am. It's a pleasure to know you're all out there. I wish we were in person, but this is wonderful that you've taken some of your evening to listen to some discussion of bird migration in the era of big data. And specifically tonight, I'll be talking about the experiences that I've had and my collaborators have had with the BirdCast project, which is now almost 25 years old in one way or another. So we have had the opportunity to study migration over a tremendous transition in technology, obviously many changes in the world, and we'll talk about some of those things today. So for those that don't know or aren't familiar, birdcast.info, please go check it out. This is the website that kind of captures the body of the research and the knowledge that we've collected over the past 25 years. At its core, this project is all about the intersection of ornithologists and birders and computer scientists. That's how it started. The idea really was very forward thinking at the time that the computer scientists, long before there was anything like the machine learning and AI discussion and application we have today, that computer scientists were really interested in thinking about large quantities of data and data that were challenging to predict, to understand, to quantify and qualify. And of course, as birders, you all know, birds represent a wonderful opportunity to study messy patterns and things that we think we understand and then suddenly learn we don't. So this was a great opportunity to kind of merge the two domains. And really at the core, the idea was to showcase the spectacle of bird migration with some of the specific applications, really to think about, can we predict it? Can we understand it and monitor it in real time? Can we take advantage of, again, 25 years ago, some of the emerging technologies that allow us to expand beyond simply our eyes and ears and the use of binoculars and microphones that we're holding on our person to much broader scales that technology allows. And one of the reasons that we were interested in doing this, despite that there's a passion for studying birds and their coolness, and that we wanted this collaboration to evolve in all kinds of wonderful scientific pursuits, at the core, we were deeply concerned. The passion for birds, of course, is only heightened by understanding that there have been tremendous declines in populations, in particular over the last 50 years. Obviously, if we could go back and really quantify farther than that, we know that we've lost a lot more birds than just 3 billion breeding birds in the last 50 years when we extend back another 100 years or beyond that. And we know that story very well. However, it's only recently that we've really been able to put some bounds on this and to understand the magnitude of what's happened, in particular I think about it as my lifetime, literally. That's a lot of birds lost, and that's a lot of change to the ecosystem. And that is at the core, really, of why I do what I do and why BirdCast does what it does. And in particular, why we focus on migratory birds. They've been hit particularly hard by these declines. We know the story in terms of why birds are declining to some extent. We don't know everything. There's still a lot, actually, we have to learn. But suffice it to say that where humans are on the planet, where our global footprint can be felt, that's a challenge for birds, and also obviously all biodiversity. You look at this graphic and you think about the amount of habitat, the landscape that's been modified by human activities, and it's enormous. Yes, there are places on the planet where maybe the human footprint is not so extreme. There are still areas with wilderness, but there is an increasing percentage of the planet's surface where human impacts are felt directly, and obviously indirectly, it's around the entire planet, wherever you look. So with that in mind, the idea that where humans are, there are challenges for birds, okay, that's a easy to understand concept for sure. I also want to highlight, though, that part of the problem in terms of where humans are and their impacts also can be part of the solution. And one of the ways I like to think about that is you look at this graphic, this is now really a year old, but every dot um, on this image is an observation from the eBird database. There are no geopolitical boundaries drawn on this graphic. This is solely where a birder or someone interested enough to submit an observation to eBird has submitted something. And you'll notice the tight relationship between where that global footprint of humanity is and where the data are coming in. Yes, there are places on the planet where people have not submitted eBird data. Oh, that's horrible. Can't believe it. But it's true. But there are lots of places where enormous quantities of information have been submitted. And right now, the eBird database is hovering right close to 2 billion observations. So a lot of data, a lot of information. And so along with that impact from the human footprint, we can think about the amazing opportunity that all of these humans, like yourselves included, that are out there observing birds, well, that can be part of this incredible sensor network of seeing, hearing, counting, understanding birds around the planet. And we can federate all that information into this database and make it available and start to study how birds move on the face of the planet, where they are distributed, and start to understand those relationships between where birds are distributed, where humans are, where the interactions are, and particularly where the bad ones are, and then think about those impacts and hopefully try to reverse those. One of the things we can do is sort of create these cool kinds of graphics. Obviously, eBird data are driven by where people go birding primarily during the day. So think about an array of species that are migrating in the spring, for example, from South America and Central America and the Caribbean into the United States. There's a list of species on the left, and the idea that we can take the eBird data that we're all collecting and submitting and understand where birds are on the planet, when, how many of them are there, their relative abundance, with what kinds of habitats they're associated, even what the trends are in their populations. This is powerful information. Right? A lot there to help us understand how birds are surviving on the planet, where they're declining, where some are increasing. That distribution information is critical. But one of the things that's important to consider about this is that this kind of stylized graphic, I want you to think about it for a minute. Obviously, there are a lot of pieces that are stylized here. One in particular that's relevant is the idea that we're thinking about primarily observations made during the daytime, but that most of the migration that's happening, most of the mechanistic movement from South America, from Central America, from the Caribbean into the United States, that's happening at night. That's when most bird migration happens. And none of the eBird data, even close to anything more than a handful, so a tiny percentage, represents actually bird migration happening at night and any information about birds actually making these journeys. So the idea of the species distribution during the day and understanding where birds are on the planet that way, super valuable. If we want to understand how birds are connecting these disparate places and connecting across hemispheres, we need additional information. Now, we can turn to a number of sources for this information. If it were maybe 75 years ago, perhaps sort of the cutting edge at the time would have been to take a telescope and look at the moon, look at a full moon. There were some wonderful applications of the moon watching approach and methodology, in particular, an incredible study from 4 nights in October in the early 50s that took almost 15 years to analyze the data from hundreds of observers across the United States that allowed us for the first time to map migration at a large continental scale. But you think about what big data meant in the 1950s and 60s. Think about several hundred observers across the continent, all watching the moon, with telescopes and reporting their observations, collating that observation set, George Lowry, Robert Newman at LSU, and taking 15 years to analyze the data set. Not terribly timely, and I think most of the people that submitted the data were still alive when the study was published, but I'm not positive about that. Regardless, the message was clear. Bird migration happens at broad scales. We can understand that it's happening at night, and there's a massive amount occurring, but we really don't know how many. You look at the published literature during that time, and you see all sorts of numbers batted around. Lots of this going on, hand waving. Tens of millions, hundreds of millions, maybe it's billions. It was a lot of birds, people knew that, but the exact number and really the extent and any kind of characterization of it, other than that there was a lot of movement happening at night, was not at all clear. But that started to change. So just as this technology, moon watching, was really starting to be something that people spent time doing, so too was the evolution in the 1950s of the first weather surveillance radar network. And it was not long before radar was developed in the early part of the 20th century that its operators realized that, oh, not only does this detect aircraft and rain and anything in the atmosphere, but that anything includes birds. It took some time to figure out that the targets that radar operators were seeing were birds. But nonetheless, very early on in the evolution of this technology and the application of it, the operators realized, oh, we can detect birds with it. And in fact, it's easier to detect birds practically than anything else, because birds are almost always in the atmosphere somewhere. Whereas rain, we don't have that all the time. We obviously don't have aircraft distributed every place in the atmosphere. So the idea that you could study the movements of birds in the air with radar was very early in the technological advance that radar brought. But it was not really until the combination of that moon watching information and the fact that these weather surveillance radars happen to be in places, in particular on the Gulf of Mexico coast, where large numbers of birds were passing, that there was the concept of, oh, we can take the direct visual observations that we make by moon watching and relate that to patterns that we see on weather surveillance radar. And we could use the moon watching as a means to quantify what we see on radar. Now, that was pioneered by a great friend of mine, a mentor, and a former major professor, Dr. Sidney Gautreaux, who still is doing this research to this day, despite being retired maybe twice or maybe 3 times from academia. And that comparison of the radar data with the moon watching data set us on the path to where we are today. Obviously, this network, which was first deployed in the late 1950s and then enhanced in the 1970s, was in the pre-digital era. This was all information that was recorded on 16 and 35 millimeter film. Thankfully, I think most of the people in the audience know what that is, but I've talked to plenty of my younger colleagues that are sort of baffled by what that is. Regardless, a treasure trove of information, but on a largely inaccessible data set right now. Well, fast forward a number of years to where we are today. In the 1990s, the first next generation radar, NEXRAD, if you will, WSR-88D Doppler radar, was deployed around the US. And by the mid-1990s, the network of 143 radars was operating and collecting data in a very new realm, right? By now, we've come out of the analog film realm into the digital era. And from the mid to early 1990s until the present, we now have a data set that's digitized, that's stored, archived, 30 plus years of radar data characterizing the air above the atmosphere above the continental US. And with that, we have an incredibly powerful opportunity to study what happens there. Yes, this is weather surveillance radar for sure. But the idea, again, that birds appear on radar, as does other biology like insects and bats, and in fact, that is often more extensive in its coverage and its timing than the weather. Well, it offers a wonderful opportunity to think of weather surveillance radar as something much more than that. And in fact, it really becomes animal surveilling radar. And if we could take advantage of the fact that, well, we know what some of those patterns of meteorology look like, And in particular, now that we've evolved into the 21st century with machine learning technology, where we can not only learn what that looks like, but remove it and talk only about the biology, in particular, the biology dominated by birds, well, then we'd be cooking with something really amazing as a way to quantify, characterize, investigate, explore all manner of bird migration across the continent for the last generation. I mean, really, really incredible potential. And that's where we are today. And that really is what it's at the core of, as I said, the BirdCast project, and what sort of the initial foray into the whole big data era was all about. Some of the things that we can now do with the information, now that we can remove the meteorology and talk about biology, we can talk specifically about birds, and we can quantify how many birds there are. Well, we can do some really cool stuff with the radar data. So we can actually create these live maps in near real time, literally maybe 10 to 15 minutes after the radar is collecting information and starts to store that information. We can analyze it and very quickly put it up into a graphic like this. Hopefully some of you have seen this. This is one of our, in quotes, live migration maps from the BirdCast site. And on it, it probably looks very familiar to you, like a weather map would, where some of the brighter colors represent more intense, in this case, bird migration. The arrows are the direction toward which birds are moving. And then obviously each of the dots, that's where the radars are. There are many green dots where the radars are operational, and there are red dots where the radars are not operational. There are also black spots on the map where it looks like maybe nothing is happening. That's not because the radars are not functional. It's not because there aren't any birds there, but those are the areas really dominated by where weather is happening, where we've removed that information. So those black holes, it's not that birds don't exist there. It's just simply that the radars are not detecting them and are dominated by other things. Regardless, this kind of an image I think is incredibly striking, both from the perspective of thinking about, oh, we can do this now in near real time. So the information is right at our fingertips to understand where birds are migrating across the continent, when, what direction they're moving, and a number of other sources of types of information that we can also provide. Now, with that said, we also can take a look at some other really striking features here. I'll call your attention to that bottom left corner, where you'll see a very, very large number. 1.188 billion birds were aloft over the US about a year ago tonight. This is the biggest night that we've ever recorded on BirdCast on using the radar data. Hopefully it's not going to be the biggest night that we've ever recorded. I'd like to think that our work in conservation and hopefully increasing populations of birds will start to see this number increase. But just think about that for a minute. Nearly 1.2 billion, right? That's give or take 4 times the number of people in the US, perhaps. It's, I don't know, like 1/8 of the human population on the planet. And that's traveling over the US by night on this particular night about a year ago. I mean, it's just staggering numbers. So this kind of presentation and the kind of data that make up the presentation, really powerful example of the path that we've traveled, the distance we've come over the 25 years that BirdCast has been operating, and in particular, the distance we've traveled since the beginning of radar technology and its application to integrate with moon watching 75 years ago. Now, I mentioned there are other data as well and other information that we can convey. So that graphical approach is wonderful from thinking about the perspective of what's happening across at a continental scale, the geography, the magnitude, the direction, the distribution. That's all really cool stuff for those people that really like to see maps. There are those people that like the finer scale resolution as well, and we can do that also. So each of those radars obviously is covering between maybe 150, 200 kilometers of atmosphere each time it's scanning. And that information is something we can summarize in what we call our migration dashboard. And this gets down really to the county or state level. So very much finer resolution than what you see in the visual on the live map. And we include a number of other things, sort of, I don't know, characteristic of what you think of in a dashboard, other kinds of metrics. And in this case, you can explore this when you visit dashboard.birdcast.info, you can take a look at it specifically for New York County, for Manhattan, which is what I'm showing here. And I'm showing 4 years of data. And obviously, some of this is going to be very small on your screen, unless you have some gigantic cinema display. Even there, it's going to be very small. But the idea that you can capture this kind of information, again, nearly in real time as it's happening, is just really striking, I think. And once you start to think about several years of information, you can start to look at patterns. One thing I'd like to call your attention to, the bottom right-hand panel there. So that was from this past Saturday night, October 5th. So that 1 million number, 1 million birds crossing New York County on the 5th, night of the 5th, early morning of the 6th, that's the biggest number that we've yet recorded in the BirdCast era and the dashboard era in Manhattan. So pretty striking to think about that number over Manhattan on a particular night. And then looking backwards in time, seeing that there are sort of similar magnitude movements that happen each October, but that was a really, really big one. And there are various reasons that that probably happened that way. All of you that have been out in the field this past fall know a lot about the easterly winds we've been experiencing and conditions that maybe haven't been so perfect for massive movement. And finally, we had a night that was really, really good coming into the peak period of migration. Anyway, the point here of these dashboard data, we can think about the number of birds aloft over the course of a night. We can look at the direction and speed that they're moving. We can look at the altitude, and we present all that in the left side of these panels. We can also look across the whole season and think about when have the pulses of migration been, and when have they occurred over the season, and also what's the cumulative total of birds that have passed through whatever area we're looking at. In this case, again, New York County. And then an additional suite of data that we present in the right side of these panels on the species that are involved. Well, I mentioned the eBird data and what we see on the ground during the day. That's where we present some information like that and start to think about how these sources of information are working together, thinking about what we see during the day in New York as the currency for what then will migrate the following night. Now that we can do all of that analysis and think about the live maps of what's happening as it's happening and the dashboard that gets us down to the county and state level, once we have all that kind of information, we can characterize that kind of information. We can do some really cool stuff with that. And in particular, we can make forecasts. So we can use the information on bird migration intensity and think about it from all of these places distributed around the contiguous US. And we can relate that information on bird migration intensity to weather data, like temperature, wind speed and direction, pressure, whether there's precipitation, any kind of weather factor that pretty much you can think of. We built a model a little more than 5 years ago, and it turned out the model was really, really good at predicting migration. For an ecological model, being able to explain about something like 85% of the variation in bird migration intensity using a small number of weather variables, the most important of which is temperature. We could predict migration. We could do it across the country. And that was a super powerful moment for us. Again, sort of one of the highlights, I think, of the last 25 years for the BirdCast project, being able to take these radar data to extract the valuable information about birds and then start to relate that to other sources of information from which we could predict where birds were going to be when, how many birds were going to be migrating, and do so in a really reliable way in which we had a lot of confidence. That opened a huge, huge number of doors for us. Obviously, it's a wonderfully valuable tool for thinking about going out in the field and understanding what times and where birds are migrating and what the intensity is like. I will remind you, as many people always sort of poke at me and say, well, wait a minute, I looked at this forecast map and it said there was going to be really massive migration and I didn't see any birds in the morning. Well, I just want to highlight this forecast map is actually very specific. It's specific to about 3 to 4 hours after local sunset, which is when the peak of bird migration in the atmosphere is occurring. So we're predicting that. It's a different model and one that I hope is going to become something that you all can access in the next year or two, a very different model that obviously models a different phase of migration. So think about this model, this forecast, as showcasing birds actually in transit. The model that, of course, you all really want to see for understanding where and when to go birding is the stopover model. And that's coming. There was a paper just recently published on that, relating the eBird data on the ground to bird migration traffic during the peak and also migration on radar over the course of the night to understand a little bit more of those dynamics. So that's coming, I promise, but it's not exactly this product. If you were hoping to say, oh, as soon as I see the forecast, I know there are going to be a ton of birds on the ground. Well, not always the case, as probably some of you have said, and now you don't have to yell at me about that anymore because you know the truth. Now, I want to take that information, and again, I want to go back to thinking about human impact. So, okay, we can characterize bird migration happening at night. We can characterize bird migration and bird distribution during the day with the citizen science data, the eBird data. And we can start to understand how does that mean birds are interacting with the world generally. And what are the kinds of issues and challenges that birds are facing in particular that are part of that decline that I talked about earlier in the presentation? So we know quite a lot about that. And I want to think about this from a couple of specific ways. Obviously, we know, yes, habitat loss and conversion, habitat pollution, whether it's chemical or sensory otherwise, outdoor cats, buildings, light pollution, various elements of climate change, all of these things are contributing to population declines. What I want to talk about here in particular, with the relationship to where birds are on the planet, in particular in the US, and where the built environment is, I want to talk about buildings and glass, and I want to talk about light pollution very quickly. So I think this graphic kind of nicely shows a little bit more of the situation. That footprint of where humans are, okay, that's a great example of kind of where we are or where we were a couple of years ago. But think about what's going to happen as we move forward. There are still major areas of expanse planned for this built environment. And the number of buildings, the square footage of glass, the amount of material that gets erected into the sky, that's going to increase dramatically over the coming decades. And I also want to think about not only that infrastructure, the buildings themselves and all that glass, but the light. We know that just from this perspective, this is the most recent artificial light at night atlas that was produced 2 years ago, I believe. And for those of you that have seen this before, it's probably as striking as it was the first time you saw it. For those of you that have never seen this before, perhaps you'll notice some incredibly alarming elements of this. The brightness and the illumination across some of these continents that dominates the continents in terms of light pollution at night is just incredible. You look at Eastern Asia, you look at India, you look at Western Europe, you look at the eastern half of the US, you look at parts of South America, and you see enormous areas of illumination and light pollution. Places where it's no longer possible to see the Milky Way or even very many bright stars. So the idea that you have this enormous built environment that's expanding and that there's a component of that that involves light pollution, this is incredibly troubling for birds. But that said, we have to start thinking like, okay, well, how does this translate? What are we talking about in terms of birds interacting with this infrastructure and this kind of experience? Well, in the US, we know from the radar data, looking across many years, in this case, probably about 20 when we did this paper, is that we can think about on an annual basis in the US alone. Every spring, the green arrows you see crossing these transect lines in the southern US and the northern US, you're talking about 2.5 to 3.5 billion birds are migrating over the course of a migration season in spring. And in the fall, that number increases, of course, because all of these birds have had offspring, some multiple of the total pair. And we're talking about approximately 4 to 5 billion birds. So large numbers of birds are on the move every year annually at night in the US. And because we can think about that, we can make forecasts for where birds are going to be when, and we also know something about where that light pollution and built environment is, we can actually take that migration forecast that you saw and turn that into a lights out kind of a tool, a place where you think, where is the greatest risk of exposure to birds on this particular night, to the largest numbers of birds and where the greatest illumination is, and make a forecast that says, oh, okay, in the red areas, that's a high migration intensity alert. That's a place where you will want to turn lights out to protect nocturnally migrating birds, to avoid them being attracted and disoriented by light into areas where they face these enormous hazards posed by buildings. This kind of a tool, taking the forecast and combining it with information we know about human infrastructure, can be a really powerful way to start the discussion and to start engaging people in particular actions that eventually you want to become just the conservation norm. We don't just want people, for example, to turn lights out only on particular nights. We want them to do it as often as possible, so we reduce as much light pollution as we can, save energy, protect human health, along with all the benefits to the migratory birds. Just an example, sort of the continental scale here. And by the way, this graphic comes from one of the partners, one of my collaborators at Colorado State University, where Dr. Kyle Horton has the Aero Eco Lab there. In addition to that kind of very broad scale approach, analogous to the forecast map that happens at the continental scale, we can also think about very local forecasts. So think about the city scale, same kind of information. Oh, for example, tonight in New York, it's not going to be a high intensity migration night. It's going to be sort of a medium night. But in Houston and in LA, the numbers are going to be high relative to their areas, high intensity nights. Okay, target those for people that maybe don't know so much about light pollution and birds, to say, hey, this is a night where you really ought to think like, oh, there's intense movement. Let's get those lights out and let's start that pattern that eventually is going to lead to people turning off lights more frequently. The idea here is that we can take the science that we've studied that relates the patterns of bird migration to weather and the forecasts that we can then create because of that, and then apply that to a specific kind of conservation action that we'd like to see happen. So this migration tool really becomes something applicable to change people's behavior, to enhance it in ways that promote saving birds. Now, just a tiny bit about some of the science behind this and where we think we're starting to have some success and where there are opportunities for, I think, sort of advances still to come, for example. Now, I mentioned we know light pollution and we know that untreated glass are serious problems for birds. The light attracts and disorients birds. The untreated glass that's reflective or transparent, birds can't perceive it. They crash into it, sometimes at night, most frequently during the day. So from the light perspective, we know now from a couple of studies, including this one on the bottom left from Chicago at McCormick Place, and one that maybe you've seen on the bottom right from the Tribune and Light, where you remove light, you reduce attraction and disorientation, and you reduce mortality. So the study from McCormick Place, we looked at the distribution of birds collected beneath McCormick Place, the bird migration traffic from radar, the weather, and the number of illuminated windows. And there was a very, very tight relationship between illuminated windows and birds that were collected, specimens that are now in the Field Museum. And that relationship was such that we could start to think about interrogating, well, what were to happen if we would have that illumination? We would reduce collisions enormously by about 50%. But even more important, if we just left all those windows, sort of unshaded or left those lights on, it would kill an enormous number of birds. It'd increase it by about 75%. So we can see that indoor lights, that modulation of light pollution coming from inside buildings, shining out of windows, turning that off was a direct way immediately. Think about reducing bird collisions. At the Tribune and Light, that study on the bottom right, again, on small screens, the detail is not so important, but the general pattern you see, that periodicity of where you see the green and gray patterns. Green is where the lights at the Tribune were on. Gray is where they're off. And you'll notice these different metrics sort of tracking those patterns. The number of birds aloft. When the lights are on, the aggregations are high. The numbers increase dramatically. As soon as those lights go off, the numbers go down. When you look at the speed of birds and the velocity, when lights are on, birds are circling, birds are slowing down, the speeds decline. As soon as you turn those lights off, the speeds are up, birds leave the area very quickly. And also another measure of disorientation, flight calls. Some of you probably know about flight calls. I'll talk about them briefly in a minute. The idea of vocal communication, expressing disorientation in birds when the lights are on, that vocal communication, the flight calling is enormously high. The rates are incredible, like literally tens of thousands over a few minute period of calls on nights when there are lots of birds. As soon as the lights go off, the calling plummets to zero. So the idea being that even with outdoor illumination, as soon as you remove that light stimulus, birds start to return to more typical nocturnal behaviors. So the idea that you can modulate indoor and outdoor lights to impact birds positively, really important. Of course, we also know that an even bigger problem is this glass issue. We've known about it for a long time, almost incredibly long, almost sort of, embarrassingly long without being able to do things about it. However, we're in a different time now and things are starting to change. This image that you see on the left, McCormick Place about a year ago, almost 1,000 birds killed just at that building. The numbers in Chicago killed that night, enormous, right? And that is all associated with light coming out of the windows, of untreated windows, that birds cannot perceive and then crash into. Now, McCormick Place had been killing birds for years. There have been studies there over the past 40 years collecting birds that are all in the Field Museum as specimen. We've had similar experiences in New York, and every city and every place where there are untreated glass structures around the country and around the world. But now we're starting to get into this period where we have solutions that can stop this. We saw it at the Javits Center about a decade ago, where treating it with glass that birds can perceive dramatically reduces the number of collisions by like 80 or 90%. We're seeing it at McCormick Place now for the first time in 40 years. Earlier this season, this kind of pattern, these decals that are 1 by 1 inch and 2 by 2 inches separated, these dots that you see all over the windows, they were deployed there for the first time. And from what I understand, the numbers of collisions have dropped dramatically for the first time in 40 years. And that's like, this data set represents something close to 40,000 individual birds killed. It's enormous. And this kind of situation, there's no reason for it anymore, given what we know about light and given what we know about glass and given what we know we can do when we alter those so that birds can perceive glass and also not experience light pollution. In New York, I like to think, oh, okay, well, we're getting pretty progressive. At least we have a couple bills on, a couple bits of legislation that are on the books that start to address some of these issues. Even though they're not perfect, and we still haven't gotten enough sponsors for 896, which, as you heard from Debbie at the beginning, you should all contact your local council people and encourage them to support this, please. Nonetheless, the idea that this information, that the science behind this spurred legislation is a huge, huge step forward. So much that, yeah, it's wonderful that New York is doing this so that we can reduce some of the at least 250,000 birds killed, every season in New York City by window collisions. But more important, as a model for other places around the country and around the world, when I show this slide, in particular in places that don't have legislation on the books, there is the sense of, why aren't we doing this? The sense of, wait, we can beat New York. There's a sense of, this is not that hard to do given that we know what to do. So a very powerful model, like I said, even if it's not perfect, even if it doesn't cover necessarily, say, all of the buildings in terms of illuminating the lights, even if it's not eliminating all light right at the moment as we speak, and that the plan is there, as long as we're getting there and accomplishing that, and we're doing so in a way that promotes getting more of this, I think we're on the right track. At least I hope so. I want to highlight another example. This is a place where actually it had nothing to do with legislation. There may be a little bit of a red-blue divide here. Who knows? Texas, a very different place when it comes to conservation legislation than New York, for example. However, with some effort contacting mayors, local business owners who have been extremely supportive of wanting to do the right thing for birds in terms of conservation, but also in terms of saving energy and promoting human health by reducing light pollution, we've had success there. This isn't a doctored photo. These are the same extents but one of them is the before lights out, and one of them is the after lights out, in terms of the Lights Out Texas campaign, and asking these buildings, not legislating it, not requiring it, but simply asking the building owners and managers to say, hey, during critical migration periods that we can forecast and tell you when they're going to happen, the peak period of 3 weeks every spring and every fall, give or take, when about 50% of the migration traffic passing through Houston is going to happen. Let's turn our lights out then and start the process of protecting birds and protecting biodiversity. And we had a huge, huge response of these people saying, yeah, we want to do that. Wasn't legislated, was just simply a decision promoted by the mayors and adopted by all of these businesses. Something we could also learn from in New York, amazingly. Now, I want to talk in the time I have left about a few other sort of evolving technologies and interesting areas to explore when it comes to bird migration and big data. So hopefully at this point in your lives, you have an appreciation for bird identification from the perspective using your eyes and also your ears. And perhaps you've had the good fortune to play around with Merlin, which I think is some really wonderful technology that employs some of this 21st century machine learning that we've heard so much about in the last couple of years, and applies it to the problem of identifying birds by sight and also identifying birds by sound. So this kind of revolution that allows you to take a picture of a bird or with your phone, or download some picture onto your phone and have Merlin identify it for you, usually correctly, but sometimes it makes some errors or does something a little funky. It's not perfect, but does a very good job of this. And to do the same thing with Sound ID to identify some audio that you hear when you put up your smartphone out in Central Park or up in Inwood Hill, something you don't know, and have Merlin be able to identify it for you. Again, not perfect, but getting better with every iteration. Very, very powerful tool, but for the expert and novice alike. For the expert, thinking about understanding what's around you, what you're perceiving and what you're not. Very helpful for the ways you actually observe the world and to tune yourself to places where you might be missing information. And of course, for the novice, for the people that maybe don't know anything about birds or are just starting to get curious, having the power of this tool in your hand is enormous for sure. We can do some really cool things with it when it comes to migration. In the last few years, the idea of using Sound ID to study bird migration at night, so to automate the process of collecting audio data on flight calls of nocturnally migrating birds. Boy, I've been talking about this for like 30 years, and it was getting to the point where I was thinking like, boy, is this ever going to happen? And it happened. It finally happened in amazing, amazing ways. Merlin was part of that. So was BirdNet, another project that's occurring at Cornell. And I think the best application of this to date is happening in Chicago right now. My friend and colleague and collaborator and former postdoc and former high school mentee Benjamin Van Doren has a lab at University of Illinois in Urbana-Champaign. And he's got this incredible project, Wings Over the Windy City, where in real time, the acoustic monitoring that's occurring at many stations around Chicago are presenting the information in a kind of a migration dashboard that's about flight calls and identifying the species. There's a species breakdown. Very, very cool. Very, very cool. So if you have interest in this, maybe I can share a sort of a secret link so you can take a look at it. Very, very cool application of the technology, sort of analogous to that radar dashboard that I showed you, but from the acoustic perspective. And an important difference, the radar dashboard, the radar data don't tell you anything about the species that are up there. The acoustic data tell you what those species are for the birds that are vocalizing. Now, we've looked forward thinking about acoustic data and obviously thinking about radar data and all the technology there. I mentioned at the beginning that we have this treasure trove of information on analog film in 16 and 35 millimeter conditions. And we've not been able to analyze even a tiny fraction of that describes bird migration in the places where the weather surveillance radars in the 50s and in the 70s, part of that first network, where they captured information about birds migrating over the US. So the idea that we might be able to look backwards in time to think about past migration and extend our knowledge, not just 30 years back for the digital data that we have from the current weather surveillance radar network. But even farther back, even as far as the late 1950s, when some of the first weather surveillance radars were deployed, by analyzing the films, there's a potential treasure trove of information about intensity of migration, where it was occurring, its relationship to weather, how it's changed. I think the potential is enormous. There's an ongoing project right now to digitize these films. It's taking quite a lot of time and money. Digitize the films, use computer vision to recognize these kinds of patterns we see, which in this case, other than what's in the top left, which is one of the first hurricanes actually detected on radar, the other patterns of bird migration that you see, and relating those to numbers of birds aloft from work that was done in the 60s and published in the 60s for how to quantify migration from these maps or these images. The potential to think about analyzing these data in a way that would allow us to understand migration going back another 50 years is, I think, just incredible. I'm very hopeful that this is going to come to light sometime in the next few years. What other things can we study? Well, obviously, we have talked about information and remote sensing. Let's think about bird biology and birds interacting with things that are happening in the atmosphere, like Hurricane Milton. Okay, a lot of questions about that have been coming up in the last days. What is Milton going to do when it comes to bird migration? There was this amazing account that came up yesterday from one of the Hurricane Hunter aircraft reporting on conditions inside the eye of Milton. And this report, for the first time to my knowledge, actually detailed that the observers were seeing birds in the eye. Now, to birders, of course, we know, yeah, birds get entrained in hurricanes all the time. We see sooty terns in the Hudson River. You see frigate birds in Kentucky, places where they shouldn't be because they're associated with these storms into which they get entrained and travel with the storms. But the idea that this hurricane in particular is a very strong one, intensified very quickly, and it's occurring in a place unlike the origin of most hurricanes out in the tropical Atlantic or even in the Eastern Caribbean, where not very intense bird migration is happening. This is happening in the thoroughfare for migration over water in the Americas. Birds flying over the Gulf of Mexico, and you kind of get the example in this slide. I was trying to kind of highlight what's happening. This is from last night. Okay, last night was a big night for migration. Over a 250 million birds on the move last night. Huge number of those birds moving in Alabama, and those birds are all moving out over the Gulf of Mexico. So think about those arrows, the directions they're moving. Think about them heading into this incredibly intense storm in Milton and getting entrained in that storm. I am certain that there are going to be something close to many tens of millions of birds or more that are over the Gulf or have been over the Gulf that get somehow impacted and entrained in the storm. What's going to come of that? We know a lot of birds die in these storms. We see feather wash-ups on the beach all the time. We see in the bellies of tiger sharks, migrants. And we also know that birds get trapped in the storms and fly with them. They fly downwind in the bands of the hurricane where the intense rains are not, but the winds are actually supporting their movement as long as they're flying with the wind or traveling in the eye of the storm. What's it going to mean? Hard to say. Probably a lot of dead birds, probably a lot of transported birds. Whether we actually see any of that, we'll know a little bit when the hurricane comes ashore, as long as it doesn't destroy the radar in Tampa. We'll be able to see what's inside that eye from the radar perspective and understand what kind of biology is there. Whether there are any observations on the ground, I don't know. I hope most people have evacuated from Florida. Obviously, this is a very dangerous storm. But the idea that we can relate bird migration to these specific kinds of atmospheric phenomena, in this case, an extreme phenomena, I think is one of the places where we can still learn an enormous amount about the patterns of migration, about how birds are navigating these kinds of and orienting around these kinds of systems, and what that might mean going forward. Similar vein, thankfully not so cataclysmic, thinking about when unusual birds show up. Everybody, every one of you in the audience, hopefully at one time or another has chased some rarity, whether it be in the park or at Jamaica Bay or maybe farther afield. Apparently there is birding outside of the 5 boroughs. So thinking about a bird like fork-tailed flycatcher that appeared at Liberty State Park a couple days ago, or the groove-billed Annie that is in Ohio, and thinking about burrowing owl that's up at Whitefish Point, understanding some of the patterns that bring about why these birds occur in these places is fun to conjecture and fun to start thinking, well, how would we study that? One of the ways we can think about that is sort of these patterns of connectivity in space and time, right? And what I like to show with these kinds of colorful maps of winds, in particular, the one with the black arrow pointing to the north, which is really kind of thinking about what has been the flow in a north-south perspective, with the greens being winds blowing from the south and the blues being winds coming from the north. What's been the prevailing pattern in the last several days that corresponds to the period when these vagrants have shown up, these largely southerly vagrants that are appearing far north of where they should occur? One of the ways that we think about this is called circumglobal teleconnections. A lot of gobbledygook jargon there. The idea, teleconnection, just simply is that there are disparate parts of the planet that are connected by some kind of flow. In this case, the flow of winds from north to south. And what we saw in the past few days, from about the 20th or 21st of September to just a couple days ago, is this real nice flow from parts of Central America and the Caribbean straight up into the Appalachians and up into the Eastern Great Lakes and into New York. And then earlier, that image on the left that you see, the pattern was nowhere near as conducive for transporting birds from the south to the north. In fact, the very much opposite is true. You'll see the arrows pointing, and I mentioned those easterly winds that kind of are the death knell for large numbers of birds to be occurring in the five boroughs during the fall. We see that kind of a pattern, that it was set up really for the first 3 weeks of the month. By and large, that pattern was sort of right over us. So the idea that we can start to relate where birds occur, where unusual things happen related to patterns in the atmosphere, I think is a really valuable thing for us to consider. I also want to highlight the idea that, well, so many birds are migrating at night. Radar is great to study it. Acoustics are great to study it. But boy, there's nothing like actually seeing birds at night, if you can, to really drive home what the species are, what the birds are doing. And with new photographic technology and taking advantage of the fact that, yeah, we do have a lot of light pollution. Hopefully, we're going to be reducing some of that. But we can also use thermal cameras, like this image in the top right here, to study, for example, birds at the Tribune and Light. Downtown Manhattan, that there's a lot of information there about what's happening at night that if we are creative, we can take advantage of. Now, I'll leave this as a quiz for all of you to be able to hopefully identify what these birds are. I can come back, just make a mental note. I'll leave them up for a little bit longer. There are only 3 birds here I want you to identify, okay? And hopefully you'll be able to. You can email me later and tell me if you get the answers right. So finally, the reason that we do all of this is that we are really thinking, okay, we've got this pattern of horrible population declines that are widespread, in particular in migratory species. But what can we do to reverse those? We can take advantage of some of the science we have. We can take advantage of the interest and the incredible community, and also this amazing remote sensing infrastructure to gather all this information, start to summarize it and integrate it in ways that allow us to then make the changes that will reverse this horrible curve and start to increase bird populations. So with that, I would like to say thank you to all of you for listening tonight. It's been a pleasure talking to you. Again, I'm sorry I can't see any of you, but I do hope to see you out in the field. I'm not always just in this little box. I do get out sometimes, and I hope to see you out in the field, hopefully for a good day of migration at some point soon. But frankly, just to see any birds anywhere would be wonderful. So thank you for your attention, and thank you again to Linaine for inviting me to do this. I hope to see you all soon. Thank you.
So Andrew, so it's Doug Fituma, Vice President of the Linnean, and I just want to say that that was a fantastic talk from my point of view. I mean, and I kept writing down questions to ask you, and I'm left with very few of them because you answered pretty much all of them as you went along. And I, you know, and you covered so much. And so many of us, I suspect, probably most of the people who have been watching I suspect relate to many aspects of what you've been talking about. And so my role now is to relay to you some of the questions that have been come in from your audience. But I just wanted to say that that was just amazing. And so I'm not sure of the sequence here. So someone asks, it's sort of a long statement with a this person asks, we live upstate in the middle of the Finger Lakes in farm and vineyard country and have noticed a dramatic decrease in insects over the past 10 or 20 years. The hundreds of moths that swirled around lights at night are completely gone, and where we used to have to refill our windshield wiper fluid monthly, now hardly any insects smash into our windshield. This seems equally true when we travel around the New England and the Middle Atlantic states. Is anyone studying this? Do the radar data show this? It seems obvious that without insects, most songbirds can't fledge their young.
That's a great question. And there is a burgeoning radar entomology community for sure. The radar data that I showed you, yes, it does detect insects, and we can start to look at this question and think about over that, for example, 30-year period, do we see large declines in insects in places? And do we see changes in emergence in mayflies, for example, out of streams in the upper Midwest? Or we can see some of those kinds of patterns. One of the interesting problems about this radar, though, is that the data that I'm talking about come from a very specific set, the WSR-88D I mentioned. It's a 10 centimeter wavelength radar. And what that means is that when that pulse of microwave energy leaves the radar and it encounters something in the atmosphere, there's a very particular density or mass to that target that it's striking and scattering back some radar that kind of defines what it's good at detecting. Really good at detecting birds, really good at detecting precipitation, okay at detecting insects. It's not the best source of information, unfortunately. We can do an okay job at understanding how mayfly populations have changed because that's a super intense number of individuals coming out of very particular points in the landscape that you can see those emergences. And you can also see, by the way, termite, like a flying winged ants and stuff in New Orleans, and that emergence that happens every spring, very cool. So yes, we can look at that, and we have seen declines, but we have not been able to look across the board for that entire 30-year data set yet, primarily because of this issue of it's not quite the right sensor to do that, which is sad because you would like to think like I have this amazing data set. I'd really like to put, sort of the 100% confidence in, okay, we can quantify what's happened with insect populations from this broad scale sensor perspective across the entire US. It's just, and for the reasons I'm saying, and for a couple of other reasons, it's just not been that easy. That said, no question, I think those declines are happening. I do think that's real. I think we also see the conversion of, this diversity of species into some monocultures of introduced and invasive species, much less diversity, maybe some of the same biomass, but different and shifted in ways. No question that this has impacts on the way birds operate and the way birds choose to forage and what that means for productivity. Absolutely. That's part of the equation that relates to this population decline that we're seeing. It's great question. And I wish I had the answer that said, yeah, we can quantify this completely and perfectly, but unfortunately we can't with this sensor.
Well, can I just remark that, my professional area is evolution and ecology of some insects. And so I've been to some extent in touch with ongoing research. In fact, I went to a conference on this just when the pandemic started. And there are people actively working on insect declines and not using this technology, but a variety of other methods. And there's no question that are massive, massive, massive declines of insects. In many parts of North America, many parts of Europe, I'm not sure that much has been done, in other parts of the world, but there's no question about it. And everyone you talk to, talks about how, they used to get smashed moths on their windshield, and that doesn't happen anymore. The summer before last, I drove up to Syracuse at night from here to go up to see a plover up on the shore of Lake Ontario, which I did not see. You know about that one. And anyway, but the point, it was really striking. Driving up Route 17 through some beautiful forested country with essentially no moths in the headlights. Um, so okay, so just going on now with this is not a question, but just a comment. Maybe those million birds brought today is Lee Kunt's sparrow in Inwood Hill Park. And I might, could also remark about the black-throated. Well, there's a black-throated gray. That wouldn't make too much sense coming from the north, out here in Stony Brook.
Let's hope so.
But no doubt about it. Question, can you please discuss the impact of hurricanes on migrating birds?
Yeah, so the question about hurricanes. So I talked a little bit about it with Milton. There's no question that birds have an interesting relationship with hurricanes. Obviously, there's been a long-standing evolution. It's not like we're seeing hurricanes for the first time. Migration, in particular, migration over water, has had to deal with hurricanes since, I think, probably let's say 12,000 years, probably more like hundreds of thousands or more, depending on what climate was doing and how much water there was where and where migration was happening. Let's suffice it to say, it's been many, many, many generations of birds that deal with these things. That said, several things happen. So in some cases, when birds are still onshore and over land and a hurricane is approaching, birds will not migrate into that. They will stay where they are. Birds are very similar to, I don't want to anthropomorphize, but think about you as a human. You can forecast a little bit about what's happening in the weather by looking at the sky and understanding changes in pressure and whether it's raining and whether conditions are favorable to do something you want to do. Other animals do the same thing, and birds can obviously sense that, and they stay put if they're in a place where they can. If they're over water, there are kind of a couple conditions that can happen. One of them is that birds get entrained in these storms. So as I was mentioning, they can be in the bands of the sort of the outer reaches of where there's wind, but there isn't a lot of precipitation, and birds will fly downwind. They'll fly with the wind. So they'll travel with the storm. And so too, birds that get wrapped up in the eye, which some do for sure, they will travel with the storm for sometimes extended periods including the transit from the Caribbean to Europe. For example, hundreds and hundreds of chimney swifts in Hurricane Wilma in 2005, getting transported from the Gulf of Mexico system to France. I mean, it's incredible to think like, whoa, this is like 2 weeks of flying, in not ideal conditions and completely over the ocean. But in some cases, birds have the machinery and the energy reserves to do this. Some of it is being prepared for migration. Some of it is flying downwind and being energetically advantageous. Some of it is probably also, if you're a chimney swift and you're an aerial insectivore, you're actually feeding on insects while you're in the hurricane, probably. So whatever the case is, that's one condition. The other one, of course, is that birds get trashed by these things in really large numbers. And we do see, whether it's a hurricane or whether it's a very powerful extreme storm in the Great Lakes, if you're walking the beach after one of these storms, you will see feather wash-ups, tons and tons. I mean, literally thousands and thousands of feathers. And also, I mentioned sort of offhand, there is a community of people in fisheries, studying tiger shark bellies. And there are many tiger sharks in the Gulf of Mexico that end up with lots and lots of migrants in their bellies because of the birds that are trashed into the water. So that combination of onshore, stay where you are when the hurricane is passing, avoid, flying in bad weather, check. Transiting with the hurricane and traveling with it to wherever it goes, and then figuring out what to do from there. In some cases, heading back where you were, in some cases, getting lost in a totally new migration system, like those chimney swifts. And then obviously, in some cases, it leads to mortality. The extent to which all of these things are happening, like how much of a population is staying put versus getting transported by the storms versus getting trashed into the water, we don't know, really no idea. Hurricane Milton might be an interesting opportunity to actually understand a little bit more about the magnitude of what can be captured in a hurricane. I don't know. We'll have to see whether there's information there. But suffice it to say, these are three kinds of things that happen. I should mention there's a fourth, which is that as a hurricane passes, birds that are near the hurricane, in particular to the west of the storm, and I won't get into the whole atmospheric circulation, but to the west of passing hurricanes, conditions are usually extremely favorable for migration. So you see these places where massive pulses of birds are moving in very favorable conditions, as the hurricane is passing far to the east. So that's kind of a fourth thing that happens.
Question from my friend David out on Long Island here. Does BirdCast have access to Doppler radars from other countries in the Western Hemisphere? Do they even have them, such as Caribbean and Central American countries, to corroborate large-scale migration models?
That is a great question. We don't have specific access, but the radar data do exist in many places in the Caribbean. In particular, Colombia has a wonderful weather surveillance radar network, and we have started to dig into those data. We made some connections there, and we learned that there are a lot of insects in the tropics and that there are a lot of bats. So that's a whole other set of new challenges, but the radar data do exist and are actually in a way organized and archived in ways that we can start to access those. So too in the Caribbean. And in particular, I think the most important network in terms of the number of radars and the availability of information in the Western Hemisphere is actually in Canada. And we are working very closely with them. The whole idea that, well, okay, the BirdCast model stops at the Canadian border. We get all kinds of flack from everybody, like, wait a minute, what's happening in Canada? Like most of the birds are breeding in the boreal forest. So what can we say about that? Well, the Canadian radar data do exist, and there are some of the same types of radars that we have here, and also some that are a little different wavelength that are in fact more sensitive to insects, but also still sensitive to birds. So yes, the radar data do exist. We don't particularly have access to them in the ways that we do in the US, because actually all the data in the US are free and available through this federally funded network from National Weather Service and NOAA, different than in other parts of the world. But the data do exist in Canada and the Caribbean and in South America, and also in Europe and in Australia and India and China, where these extensive networks exist, and where BirdCast, the way we use it here, is absolutely possible. We're hopeful that this kind of thing is going to expand. It's kind of a geopolitical and data access issue. It's not the data exists, and the potential to do this kind of thing, just relating information and using the existing tools from machine learning technology to analyze the data. We have all that. We just need access to it, and we need the geopolitics to be a little bit better to actually get the data, in particular in China.
Carrie asked two questions, and one of them I think you just largely answered. About whether or not BirdCast purchases data sets and rents radar time and bandwidth, or whether the data are in the public domain or open sourced.
Yep.
And,
Public domain and open source.
And you could say a few words, because I think you largely answered that, and then move on to Carrie's other question. Are modern, just a minute, something got switched here. Well, I seem to have lost that question, but I think it was to the effect whether you can identify any individual species in any of these data, or whether you're really just looking at total numbers of birds.
Yeah, right. So on the first side, yeah, so all the US data are in the public domain. And so NOAA, National Weather Service, federally funded taxpayer dollars, all accessible information, and more accessible than ever now, because there's a relationship between Amazon Web Services and NOAA to host that data and make it available, and actually be able to run our analyses in many parallelized high performance computing environments. So it's much faster and much more efficient. So that's on the one hand. When it comes to species ID with radar, it's extremely challenging. The only way really that you can feel confident in doing it is sort of post hoc. There's a large number of broad-winged hawks, Swainson's hawks, and turkey vultures moving through Texas or Greenwich Audubon or wherever you are where there might be a radar. And you can see those patterns on radar, very particularly hawks migrating, the streams of them, the kettles, etc. You also can see roosts of birds, roosts of blackbirds, crows, purple martins, tree swallows, etc., and detect what those are and relate it to observations. The actual identification from the radar data, I suspect that if you were able to access the radar data at their rawest possible sense, which we don't have access to, and in fact, even the radar operators don't have access to, right as they come onto the radar, that literal every bit of information about the microwave energy that goes out and what comes back and how it comes back, I suspect there might be a little bit more information there. But in generally, speaking about, sort of other radar sensors, you can identify wing beat frequency of individuals. You can start to get at species IDs or at least family IDs that way with certain types of radar, not the one we're working with here that's weather surveillance radar, much, much smaller scale marine type radars and tracking radars and things like that. But in general, it's not a great technology for identifying species. You kind of want to leave that to the other kinds of data available, like the acoustic information or the direct observation at night.
So I have a comment and then questions from two people. One, Diane says, fabulous presentation. Thank you. Let's see, I'm getting some of these, my questions keep disappearing on me. And Alex says you mentioned a paper about the stopover model in the works to predict daytime birding conditions. Could you share the title or link?
Yes, I'll probably the best way.
There's one many people will be interested in.
Yes, I can pass that along. I can send it to I can send it to you guys and email it to you, and actually email you the paper. It's a wonderful colleague of mine, incredible birder. Any of you who have been to Switzerland and have found anything rare have probably had him review your observations. Raphael Nussbaumer, who is at the Swiss Ornithological Institute and was a postdoc at the Cornell lab for a while. I'll share the paper with you, and it's the first of hopefully many to come that starts to relate this idea of the very last of an evening's migration data to what's actually stopping over on the ground. Very, very different kind of analysis and modeling than what went into the forecast models that we were talking about before. So yes, I can share that. I will pass it along, and it can be distributed.
Yeah, I mean, maybe you send that to the Linnean and we could post it somewhere. Again, we've got multiple questions here. One is, I don't know how you're going to answer this one. Why are bird-friendly laws so difficult to pass and convince legislators the importance of?
Why are it amazes me that they're as difficult as they are to pass. Although at this point, it seems like any law is difficult to pass. So it's not just
I think this question has very broad application.
I agree, but I do think that generally, I think that there's this fundamental disconnect between the way that I think when people understand about birds and the environment and all of the things that they provide, whether it's the ecosystem services or whether it's that, 1 out of every 3 Americans is watching them, and it's $40 billion of, input into these small communities around the country, whatever it is, there's a disconnect between that and thinking about like, oh, we can actually do things in the way we behave that don't change our standard of living from the perspective of like, well, okay, like I don't need my lights on all night in my building. I can turn them off when I don't need them, for example. Or yeah, I get used to seeing little dots on the outside of the windows so much to the point that I don't actually see them anymore, but birds can see them, so the birds aren't colliding. That disconnect, I think it's an education issue in part. I think that's a big component of it. And I think it's a literal disconnect of like, how do you get people to see what's happening? I think we're doing a better job of that in the last 5 years than really at any point in the last 25 or 30 years in terms of being able to take these kinds of metrics of like, oh, 1 million birds flew over New York last night. Would have been great if you had passed this law so that we don't have thousands of dead ones on the ground, eliminating pollinators, et cetera, et cetera. Being able to talk about that stuff now is starting, I think, to hopefully change the tide. But as to why you would not do something so simple as this that would have very little impact on the humans, but would have a great impact on the environment around us, that is just like a serious sociological fail as far as I'm concerned.
Right. And one of many such. I have a specific question here and then sort of a more general one. If you don't mind, the folks here, I will ask the specific one first. Is there an understanding of why night migrating birds are drawn to artificial light? Are they hitting lighted buildings on their downward trajectory toward the end of the night? Or are they coming down to the light from the middle of the night when they are at their cruising altitude? Yeah, I mean, that's a good question.
It is a
Why are
good
all those
question.
birds hitting all those buildings?
Yeah, the answer is yes. So at different times, birds are doing different things, right? We don't know very much about it, but we do know that there is some collision at night. Every time people have looked for it in studies where they've gone out and done collision monitoring around buildings throughout the night, they found birds colliding at night. But most of the collision happens in the morning after. So how does the light fit into it? So yes, the light is attracting birds. The light is disorienting them. The attraction piece, what's going on there is some deep evolutionary historical element that I don't think we fully understand, other than it presumably connects to somewhere back in ancestral times of one, light being something to which you can orient that either means there's food or energy or safety or something that propagates up the evolutionary tree. Very simplistic way of thinking about it, but I suspect there's something there that we don't know the answer to yet, but probably is part of the equation. In terms of orienting, like why you would be attracted to light versus not. Now, the disorienting piece, we are starting to learn something about. Fascinating thing that delves into the biochemistry and the physiology of the way birds orient and navigate, the cue systems they use, in particular, magnetic cues, being able to sense the Earth's magnetic field, something that we're still learning about now that we think over the last 50 years or so, we've started to grasp like, oh, birds can actually orient to this. And oh, electromagnetic interference of various types really fouls with that cue that birds are using and that whole sensory ecology that they use. That's where the disorientation piece comes in. Different wavelengths of light interacting, for lack of a better, simpler description, with a molecule in the eye that basically is orienting to patterns in the magnetic field that allows a bird to take advantage of that unique information of position and intensity in the magnetic field. And when light comes in and disorients that, light of a certain wavelength, it sort of makes that molecule orient and move in different ways. There's some physics to it. There's some quantum ecology to it, crazy stuff that we don't really understand. That's likely what's going on. So that attraction and disorientation is a combination, presumably, of evolutionary history, as well as actual physiology of the individual. And what that means is that, yes, birds are attracted to light when they're in landing phase and they're coming into areas where they're coming close to buildings. They are attracted down from as high as 4 kilometers up. We've seen maybe even higher at the tribute in light, and as far as 10 kilometers away. That's what we know. We know it could even be farther than that. So there's local scale attraction and disorientation. There is much greater sort of like regional type scale, in particular when it comes to thinking about the sky glow of cities and how far away you can perceive a city. So all of these different factors of scale, both at the individual to sort of the evolutionary history of the organism, to its morphology, how big are its eyes, and what's it perceiving at night and what kind of cues are it using. All of these pieces of the puzzle are part of the disorientation and attraction piece that we know is happening, and we just can't really understand exactly why just yet. But so it's happening also throughout the night at different times, landing phase, transit phase, and also reorientation phase and morning flight phase, where birds are reorienting in the morning. If they've been drifted way off course by the wind, like strong westerly winds, birds get blown out, say over Long Island, and they're all flying back to the west and north to get back to better habitat in the daytime. Birds are crashing into things then. So it's this combination of what's happening at night during the different phases, the individual to that history of the species, etc. A whole lot of interesting interacting features here that I think are going on, which I hope we'll be able to answer confidently one day. Like, okay, here's the exact reason. But these things are interacting and complex right now.
So here's the rather open-ended question here, and there are a couple more yet to come. And this person says, please share more on Chicago's wings over the Windy City. Do you have anything more you would like to say about that
I
program?
can say some more about that. Yeah, I will direct you again to a website where you can learn more about that. Benjamin's project is pretty amazing, where it really is sort of the cutting edge of thinking about how to use acoustic monitoring technology in an urban area to automate the process of identifying what birds are passing where across this transect that looks at different degrees of urbanization and greenness and so on. But that also relates thermal imagery of how birds are behaving when they're around buildings, and then obviously educating the public about that. Really, really fascinating. I'll share some information when I share it sounds like I have a sort of an action item list of things to share, and I will include that in the mix.
Okay, thanks very much for that. Okay, here's the question that had disappeared, has reappeared. Are modern radars able, did we already have this? Are modern radars able to see individual birds?
We sort of have this question. Yes, some radars can absolutely see
That's what I thought.
individual birds. The weather surveillance
That's what I
radar,
thought, yeah.
yeah, weather surveillance radar we're using, it can detect an individual bird like, 75 miles away. But the information there is minimal. You'd use a different kind of radar, but yes, absolutely. There's no question that you can study flock structure, again, wing beat frequency, details of how birds are coming in and out of roosts, all sorts of cool information with smaller scale radars. In particular, one that I really like and have some colleagues that developed called the BirdScan radar, that is a Swiss unit that can do wing beat frequency, and they've been relating the wing beat frequency to imagery to make sure they can identify the bird's property and properly, and then feed that back into a machine learning model that extracts from the radar data all those wing beat frequencies to identify, oh, that's a wagtail. Well, not here, but maybe here, maybe sometime, but that's a wagtail, or that's a lapwing, or that's this is waterfowl or a wader. That kind of stuff is absolutely possible, and for individual birds, for sure.
I just have just a quick little note relative to the previous question, and then there's another question to come. And that is when we're talking about why birds orient toward light. I should say that same question has been asked a long time ago about insects such as moths. And one hypothesis, which the leading hypothesis, which I think has some evidence, and I'm not sure how good the evidence is that insects would often use the moon or some other celestial body as a point of reference with respect to maintaining a consistent direction. So you always, keep the moon at 25 degrees to the left of where you want to go or something. But if the moon is actually only a rather few meters away from you, namely a streetlight or something, then what's going to happen if you follow that rule of behavior is you're going to circle in around it and then go around and around and around. Which is, I think, that's sort of relevant.
Sure.
And we have here, thank you for what a clear and complete presentation. And wonderful presentation. How big is your team at Cornell, and will AI accelerate your work?
Yes, AI is definitely accelerating the work. It's not taking this human or others out of the loop, and we're fully engaged with it. It's not eliminating us at all. The team is relatively small at Cornell right now. It actually is really only 3 people per se in terms of the radar data. Myself, Adrian Doctor, and Alex Tedeschi. There are a universe of other now people that have been postdocs at Cornell that have gone off to found their own labs, like Kyle Horton at CSU, Colorado State University, I mentioned, Benjamin, who is at Illinois, and there are others around the world as well, including a couple of other postdocs, I think, on this meeting that are going to go set the world on fire. So Shannon Curley, I think, is still on the call, and is definitely part of the team too. So it's a relatively small number, but the impact of it and the partnerships are making it a lot bigger. And I hope that it's going to be growing quite a lot more as time goes on. We certainly have enough information to last a lifetime to go through. And AI is helping that, by the way, and for sure. The machine learning is a big part of that.
Andrew, thank you so much for a really interesting presentation that I think all of us can relate to in many different ways. And we'll certainly, look forward to seeing you around birding in and near New York City. I don't know if Debbie has anything that she would like to add at this point, but if not, thank you so much. And I remind the audience that your talk will be posted on the Linnean website. So if you didn't catch all of it, or you have friends who you think should have been here, and the answer is yes, you do have friends that should have been here, that you'll be able to see and hear Andrew's really interesting talk. Thank you so much. Okay. Good night.
Thank you,
Good night,
Andrew. That
everyone.
was great.
Have a great night, everyone. See you out there.
Okay.